This PIR motion detector nightlight project is sponsored by PCBWay. In the workbench area, the light switch is in an awkward location behind a door with all sorts of trip hazards around if it's too dark, and it started making sense to have a motion-activated nightlight in the area. So I got one of these PIR motion detection modules and started testing. I have the HC-SR501, and these have a 3-pin header to give power to the module and have an output signal for motion detection. And there's a couple of potentiometers to control the sensitivity area that the sensor can detect within, and how long the output signal will stay triggered once activated. There's a couple of data sheets for this module that I found. So here's the description of the 2 potentiometers and the 3-pin header. I didn't change anything with this jumper, so I'm using it in default mode. And this time delay adjust is the one that controls how long the output stays high when you detect motion, up to 5 minutes. The other one controls the range from 3 to 7 meters where you can detect motion. The module can be powered between 5 and 20 volts, and the output goes between 0 volts and 3.3 volts, where 3.3 means motion is detected. And I'm going to be hooking it up to an ESP8266, similar to this, where I'm powering the module from 5 volts and then reading the 3.3 volt output on a digital input. Looking at a different datasheet for the module, they included a schematic here. So here's an onboard 3.3 volt regulator that can take, I believe, up to 25 volts in. So that's where they give their rating input voltage 5 to 20. But really it's a 3.3 volt circuit, so we have a 3.3 volt output from this chip here. And there is a feature here. If you install a light-dependent resistor, because mine didn't have one, it can change the behavior so that we only detect motion and generate an output if the ambient light is dark. So when we have a night light, we don't want the light to turn on in the middle of the day every time we walk past this sensor. So by installing the LDR, this is only going to respond if it's dark and you walk past the sensor. So I noticed on the circuit board there's 2 areas with a 2-pin through-hole header. I tried tracing out the circuit to see where one pin will go to ground and the other pin will be associated with a 1 meg resistor and this pin on this chip. So it looks like this header here close to the power and output header is the one that would take the light-dependent resistor. So this plastic dome can just lift right out, and the light-dependent resistor can be placed right here and soldered on the bottom side, and then the ambient light can control the behavior of the module. So on the schematic for the board I'm interfacing this module with, the sensor will connect to a 3-pin header where I am providing 5 volts and ground from the WeMOS USB power coming in, and the sensor's output will come here to digital 6 as an input. And I threw this arbitrary capacitor here because the module's output has a series 1K resistor before the output signal, and I can use that with this capacitor to ground as a low-pass filter. Just in case there's any noise on this signal, I can try to clean it up a bit and minimize multiple triggers. I'm not using this UART right now, but if I wanted to get some debug serial out or something like that, I can hook it up here. And in the sketch, when motion is detected, I turn on a relay here through an optocoupler so I can have this isolated, especially if I'm going to use high voltage on this side, and I'm using the isolated 5 volt switching regulator that I've used a lot before to provide isolated 5 volts to control this relay as well. So when motion is detected, the input goes high, then this relay control goes high, turning on this optocoupler's transistor, turning on this relay driver transistor, and turning on the relay. And I'm using the Songle 5 volt coil relay and screw terminals so I can connect 120 volts AC if I want and directly control some sort of a lamp. But in this case, I'm just staying within 5 volts. So I'm going to use it to switch on some LEDs I took out of a spare old flashlight. The reason I wanted to use a processor instead of directly controlling a relay from the sensor is, first of all, so I can have control over the timing and change it a lot easier than messing with those potentiometers directly on the sensor. And also, I can implement wireless features. For example, if I had 2 of these lights, when one triggers and turns on its light, I could wirelessly tell the other module to also turn its light on because somebody is now in that work area. The sketch that controls this is short. I'm just setting up an input pin for the sensor, an output pin for the relay, and I'm setting up a timer here. I currently have it for 10 seconds. So as soon as I trigger that there has been motion detected, I will turn on the relay for 10 seconds, and I configured this motion detector to basically shut off the output as fast as it can. So if it detects motion, it's just going to go high momentarily and then low, and I'm controlling the actual on time specifically from the sketch. So in the main loop, I'm just constantly reading the sensor input. When it goes high, start the timer, turn on the relay, and then just keep checking has 10 seconds passed, and if so, turn the relay off and wait for another trigger. Before I had installed the light-dependent resistor, I tested the module on the workbench just to make sure it responds at all, and with the LDR installed, I verified the light only comes on if the room is dark. To mount the PIR sensor, I found an enclosure on Thingiverse that would allow it to mount on an angle and allow some position adjustment, so I can mount this near the ceiling and have it aiming down and then adjust the area that it can monitor. After a few failed attempts, I had the enclosure printed and I mounted the sensor inside. With everything ready to install, I attached the light and sensor to a junction box so I can easily mount it for testing. The PCB can just sit somewhere temporary for now, and everything is running on low voltage, so I just need to plug the USB cable into a charger and see how it all works. With the motion sensor aimed at the area that I'd be entering from, and with the light angled toward the wall light switch, once the area was dark, I walked toward the motion sensor and the light came on, allowing me to safely navigate to the light switch. In the future, I may change to a better light that's more of an ambient room light instead of a specific spotlight, so I can light up the area better, but for now, the prototype works.